Problem 2, page 133. Consider the adjoining figure where ABCD is a square and AEB and CFB are two equilateral triangles. So since AEB is an equilateral triangle, then of course AE equal EB equal AB, which is equal to AD, DC, CB equal BF, and CF, because these two are equilateral triangles. Now consider the system A, AB, AD. So this is the origin, 0. On the x-axis, if you want to consider this as the x-axis, okay, this would be 1, okay, and if this is the y-axis, of course AD, then D would be 1. So at D we would have 1. So you can think of it as such. Now, we want to find the coordinates of A, B, C, and D. Of course, A is the origin, so it's 0, 0. B is here, so it's 1, 0. D is on the y-axis at 1, so it's 0, 1. So these are obvious. Now, clearly, C would have coordinates 1, 1. Okay? You can think of it directly this way, or you can say, for example, OC is equal to OB plus OD. AC is equal to AB plus AD. Okay, this means that the coordinates of C are 1, 1 because AC is equal to 1AB plus 1AD. So we were able to write it as a linear combination of AB and AD with coefficients 1, 1. Okay, but here it's obvious, so we can write it directly. Now, part B, find the coordinates of E and F. Now, here is where the work starts. How do you find the coordinates of E? Now pay attention, in the book they forgot to label this E, so please fix it. How do we find the coordinates of E and F? So to find the coordinates of E, I want to write AE, because A is the origin, as a linear combination of AB and AD. So this is our goal. How do we do this? Now, what do we know about AE? If I take here the midpoint of AB, okay, so let's call this point I. I called this I. I is the midpoint of AB. This means I can say that AE by Chazel's rule is equal to AI plus IE. Okay, so this is what I did as a first step. Now, what's AI with respect to AB? AI vector is equal to half AB because I is the midpoint. So I replaced here AI by half AB. Now I still have to deal with IE. Now notice that IE is parallel to AD as a line. IE is parallel to AD. Can I write IE in terms of AD, IE as a vector in terms of AD? Yes, because they are parallel, so they have the same direction. So they are collinear vectors. But what's the multiple? So IE is equal to what multiple of AD? This is the question that we need to answer now. How do we find IE? Now, since the whole thing AEB is an equilateral triangle, then the AEI, I consider here AEI, this is a semi-equilateral triangle. Now, you can do here one of two things. Either apply Pythagoras theorem to find IE, or if you know the rules for the semi-equilateral triangle, you can apply them directly. So in a semi-equilateral triangle, I will remind you, if this is the hypotenuse, notice this is the hypotenuse, this would be h over 2, the hypotenuse over 2, and IE would be the hypotenuse times radical 3 over 2. Okay? So, I applied it here directly. If you don't want to do this, you can apply Pythagoras theorem to find IE. Now, I applied it directly because this would give me that IE is h, which is AE, radical 3 over 2. But I know that AE is equal to AD because of the properties that we said. So AE is equal to AD. So this is the same as AD radical 3 over 2. Now AD is 1. I can replace it by 1 if I want. But there is no need. I kept it as such on purpose. Why? Because now I know that in magnitude, IE is equal to radical 3 over 2 AD. But IE vector and AD vector have the same direction and same sense. So they have the same direction, same sense. And the ratio is radical 3 over 2. Therefore, I can say that IE vector is equal to radical 3 over 2 AD vector, which I did here. Now, what do we do next? I have this. I can replace it here. Okay? So replace it here. What do you get? When you replace it, you will get AE equal half AB plus radical 3 over 2AB. So we were able to write AE as a linear combination of I and J in our case, which are AB and AD. The coefficients are half and radical 3 over 2. Therefore, the coordinates are of point E are half radical 3 over 2. Now, to find the coordinates of point F, I need to write AF as a linear combination of AB and AD. Now, what I did here, I took J to be the midpoint of BC, okay, because I want to find this horizontal distance from A till here, okay. Now, notice that this is nothing but AB plus JF. So I took J to be the midpoint of this segment BC, okay, and this means I can split the vector AF as AB plus BJ plus JF. Okay, now AB is in terms of AB, it's 1 AB. BJ is equal to half BC, which is the same as half AD, so this is obvious. I remain with JF. How do I find JF? Notice that JF as a vector, it's parallel to AB. So I can write it as a multiple of AB, but I want to know what multiple of AB it is. We know by the same argument, this using semi-equilateral triangles, I can show that this JF is equal to H radical 3 over 2, and H is the same as, let's say, BF, and BF is the same as AB, so this is equal to AB radical 3 over 2. Now, notice also that vector JF and vector AB have the same direction and same stance. So I can say that JF vector is equal to radical 3 over 2 AB vector. Okay, so this is what I explained here. So JF vector is equal to radical 3 over 2 AB. Now substitute it here. So we said AF is AB plus BJ plus JF, which is AB plus half AD, plus now JF is radical 3 over 2 AB. So I put it here. Take AB as a common factor. So we get 1 plus radical 3 over 2 AB plus half AD. This means that the coefficients of vectors AB and AD are the coordinates of point F. So F is 1 plus radical 3 over 2 half. Part C, find the coordinates of DE and DF. So we apply the rule for finding the components of a vector. DE is XE minus XD, YE minus YD. We substitute and do the calculations. We do the same thing for DF. And we find the components of the vectors DE and DF. Now, part D, show that DE and F are collinear. Now, since we already have the components of vectors DE and DF, we can apply any rule we want. We can, for example, apply X over X prime, Y over Y prime, and check if they are equal, because here these are non-zero, so we can apply this. Or we can apply X times Y prime minus Y times X prime and prove that it's equal to 0. And this is what I did here. So using the components of the vectors DE and DF, I did X times Y prime minus Y times X prime. And using the calculator, you can check that this is equal to 0. And this means that the vectors DE and DF are collinear vectors, so they have the same direction. So lines DE and DF are either parallel or confounded. But since they share a common point, which is point D, then of course they have to be confounded, and therefore the points are collinear. Problem 4. Consider a rectangle OABC. I constructed this here. And given the dimensions of the rectangle, OA equals 6 centimeters and OC is equal to 4 centimeters. And the system OUV, so it's like OIJ, they called I and J, U and V here. O is the origin, so 0, 0. U is 1 over 6 OA, so I drew here U to be 1 over 6 OA. Notice OA is 6 centimeters, so U would be 1 centimeters in magnitude. Similarly, V is 1 over 4 OC. OC is 4 centimeters, so so V would be 1 centimeters in magnitude. Now, M is the midpoint of OA, and N is the midpoint of OC. Part A, find the coordinates of OABC, M and N. So, it's very easy. O is the origin, so it's simply 0, 0. A is the point here. Now, this is 1. So, if this is 1, then this means, so this is 1. So, 2. M is at 3. This is 4, 5, and this is 6. So, A is 6, 0. It's on the x-axis. B is 6, and you have here 4, because this is 1, 2, 3, and 4. Okay, so, and C would be 0, 4. Now M is here at the midpoint of OA, so it's 3, 0, and N is 0, 2. Part B, F is the point defined by OB equal 3OF. Show that F belongs to CM and give a geometric interpretation. So first, we need to find the coordinates of point F. Since OB is equal to 3OF, then OF is equal to 1 over 3 OB. So this means that XF minus XO, which is simply XF because XO is 0, is equal to 1 over 3 XB. And YF is 1 over 3 YB. We substitute the coordinates of XB, the coordinates XB and YB here to get 2, 4 over 3. So F is 2, 4 over 3. Now, they said we want to show that F belongs to CM. This means I can take, for example, vector FC and FM, or MC and MF, any two vectors having these 3 points, and show that they are collinear vectors. So what I did here is I took vector FC and FM, find their components, so XC minus XF, YC minus YF, XM minus XF, YM minus YF, and I found the components of the vectors. Then you can apply any method you want. You can say, for example, X over X prime, Y over Y prime, and show they are equal. You can find XY prime minus YX prime and show that it's equal to 0. Or you can simply notice that FC is equal to minus 2 times FM, and you conclude that the vectors are collinear. Here I did first XY prime minus YX prime, so minus 2 times minus 4 over 3, minus 8 over 3 times 1, and I got the answer equal to 0. This means that the vectors FC and FM are collinear vectors, but since they have a common point, which is point F, then we can conclude that the 3 points are collinear, and hence F belongs to line CM. So here I drew the figure. I drew F first as such that OF is equal to 1 over 3 OB, okay? And then we showed here F and C and M are collinear, so you can see clearly that they are collinear. But they asked for something else here. They asked for a geometric interpretation. Now, notice F, C, and M are collinear. And notice from the beginning, from here, I told you that FC is double FM times minus. So FC is minus 2 FM. Okay, so notice FC is minus 2 FM. And we know that the center of gravity of a triangle cuts the median into into 2 parts, where the first part is 2/3 of the whole thing, or the first part is double the second part, the second part is the third of the median, and so on. So here we have this property. Notice, since FC is equal to minus 2 FM, then this point cuts the median CM in triangle OAC into 2 parts. The first part, the upper part, is double the second one in length. This means that F is the centroid of triangle OAC. Now, part C. G is the point defined by NB equal 5 and G. Find the coordinates of G and verify that G belongs to CM. Now, since NB is equal to 5 and G, this means that NG is 1 over 5 NB. So XG minus XN is equal to 1 over 5 into XB minus XN. And similarly for Y. We substitute the coordinates of XN and YN and B. So XN is 0, XB is 6, XN is 0. We can do the calculations. We get XG equal to 6 over 5. We substitute YN here, 2, YB is 4, YN is 2 again. So YG is equal to 12 over 5. I constructed here the point G. Now let's go back to the second part of this question. So we found the coordinates of G. The second part is verify that G belongs to CM. To do this, we can consider any 2 vectors, for example, GM and GC, CM and CG, CM and MG, whatever. Choose 2 vectors and show that these vectors are collinear. Here I chose vectors CG and CM. Okay, so find the components of CG, find the components of CM, XG minus XC, YG minus YC, XM minus XC, YM minus YC. Doing the calculations, you get these 2 vectors. Now, to check that these 2 vectors are collinear, you can use XY prime minus YX prime equals 0, or you can show that X over X prime is equal to Y over Y prime. Now, here I chose this method because everything is non-zero, so I can divide. So 6 over 5 over 3 is 2 over 5. Minus 8 over 5 over minus 4 is also 2 over 5. Since they are equal, then this means that CG and CM are collinear vectors. And since they have a point in common, which is point C, then they are the lines CG and CM are collinear, which means that points CG and M are collinear. Now, this means, of course, that G belongs to Cm. Now, the last part, part D, find Cg as a linear combination of CO and Cb. So, back to the figure, I want to write Cg as a linear combination of CO and Cb, CO and Cb. How can we do this? First, notice something about Cg from here. Cg and Cm are collinear vectors, so it means I can write one of them as a multiple of the other. Notice here, what multiple is Cg of Cm? Since Cg, x over x prime is 2 over 5 and y over y prime is 2 over 5, this means that this one, Cg, is equal to 2 over 5 Cm. If you get confused which one is equal to 2 over 5 times the other one, you can think of it this way. Although you cannot divide vectors, but on Scratch you can do it. Cg over Cm, okay, it's like Cg over Cm, because x over x prime is 2 over 5 and y over y prime is 2 over 5. So as if you're saying Cg over Cm is 2 over 5, which means that Cg is equal to 2 over 5 Cm. But do not write this, please, because this is mathematically wrong. You cannot divide a vector by a vector. Okay, so you do it for yourself on Scratch, just to know which one is 2 over 5 times the other. So since the upper one divided by the lower one is 2 over 5, this means that Cg is equal to 2 over 5 Cm. Now, so Cg is 2 over 5 Cm. What do I know about Cm? Since M is the midpoint of OA, I know that Cm is equal to half into CO plus Ca. This is one of the basic rules of midpoints. So since M is the midpoint of OA, then Cm is half into CO plus Ca. Now, what do we have here? So half CO, so 2 over 5 Cm. Cm is half of CO plus Ca. But I want to write everything in terms of CO and Cb, not Ca. So I will insert here letter B. So inserting here letter B, what do we get? We get CO plus Cb plus Ba. Okay, so now I have CO and Cb, but I also have Ba. What's Ba from the figure? Let's go back to the figure. Ba vector is equal to CO vector. So I can replace Ba by CO. So here I replaced Ba by CO. Now, CO plus CO is 2CO plus Cb, then expand, so you get 1 over 5 times 2 CO. So 2 over 5 CO plus 1 over 5 Cb.